Hey everybody, in this video we're going to practice implicit differentiation. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. The idea of implicit differentiation really comes to us after we've done chain rule. And the idea is that, well, if you have a relation, not a function, but a relation between x and y, where y can't be isolated, how do you find the derivative? And so what we have right here is an example of circle. X squared plus y squared equals 9. That's a circle centered at the origin with a radius of 3. Now we could solve for y. We could subtract x squared and we could take the square root, but that's going to involve a lot of chain rule when it comes to taking the derivative. And what we're going to do is we're going to show that there's a little bit of an easier way to find the slope. So what we do is we treat y as its own function, because it is. It's just not isolated. It's not explicit, not by itself. So when we want to go to take the derivative, we say, well, what's the derivative of x squared? We know that. That's 2x. What's the derivative of y squared? Well, if we think about it, y is the inside function and squaring it's the outside function. So this is working just like chain rule. So the way it would work is we would take the derivative of the outside function, so this would be 2y, times the derivative of the inside function. In this case, well, we don't know what the derivative is, but we can just write it as dy dx equals, and the derivative of 9 is 0. And so we have this expression dy dx, but we don't know what it is. But now we can algebraically solve for it. So to do that, we subtract the 2x over to the other side. So 2y times dy dx equals negative 2x. And so now we'll divide by 2y. dy dx equals negative 2x over 2y. And that simplifies to negative x over y. That's our derivative. One of the hallmarks of implicit differentiation is that our derivative is not going to be exclusively in terms of x. It's also going to be in terms of y. And that's because a single x value may not determine a point. You may need a y value to determine a single point. So let's try another one. So with this one, this is an ellipse, also centered at 0, but it still works along the same idea. If we want to take the derivative, 25x squared, that becomes 50x plus 9y squared. Again, we treat y as its own function, with y being the inside and the squared being the outside. So when something is squared, it becomes 2 times that. So 18y, and then we take the derivative of y, dy dx. The derivative of any constant is equal to 0. So now we'll subtract the 50x, leaving 18y dy dx equals negative 50x, and we'll divide the 18y. dy dx equals negative 50x over 18y. And we can simplify that, canceling out a 2 from both, negative 25x over 9y. Let's try another one. Now here, this is a more generalized version of problems 1 and 2, where here we have a, b, and c as constants. So the derivative of ax squared is going to be 2ax. The derivative of by squared is going to be 2by times dy dx. And the derivative of c, any constant c, is just going to equal 0. So when we want to find dy dx, we subtract the 2ax to the other side. So 2by times dy dx equals negative 2ax. And then we divide by 2by. So dy dx is going to equal negative 2ax over 2by. y. And the 2's cancel like they did in problems 1 and 2. So we have negative ax over by. Now this follows the example of problems 1 and 2, but this is a generalized solution. So anytime you have a circle or an ellipse, the slope at any point is going to be based on this rule right here, where we plug in the x and y coordinates and we take the constants a and b into consideration. Interestingly enough, the value of c, which determines how big the circle or the ellipse is, doesn't enter into this. Let's move on to number 4. Number 4, this one often gets people because they forget that x, y is a product, which means product rule comes into play here. So that means when we do product rule, we first take the derivative of x, which is 1, and leave y alone. Then we leave x alone, and then find the derivative of y, which is dy dx equals 10. So now, oops, my mistake, that is not 10, that is 0, that is a constant. So now what we have to do is we want to find dy dx, so we subtract y. So x times dy dx equals negative y. So dy dx equals negative y over x. Again, this is a very important thing to remember. When you have x and y, those are two separate things now, and so they have to be treated as a product, not as one term. Now, for this one takes that idea a little bit further, where here x is being squared and multiplied by y, and here y is being squared, but also being multiplied onto x. So here we're going to have product rule twice. So for this first one, x squared, when we take that derivative, becomes 2x times y. We leave y alone. Then to that we add x squared, we leave that alone, times the derivative of y. So times dy dx. So now we found the derivative of this first term. Now we find the derivative of the second term. Derivative of x is 1, and we leave y squared alone. Plus, we leave x alone, and multiply by the derivative of y squared. And we've seen this already in problems 1, 2, and 3. That's going to be 2y times dy dx equals 0. Now at this point we have 1, 2, 3, 4 terms here, and we want to get dy dx by itself. And this often mystifies students as to what to do next, because we have 2 dy dx's. Well, let's remember our algebra. What we want is we want to get 2 of these into 1. So what we're going to do is these 2 terms right here, we're going to leave. But the other 2, the y squared and the 2xy, they do not have a dy dx, which means we're going to move them to the other side of this equation. So on the left side, we have x squared times dy dx plus 2xy. I combine these two, and it's a common convention that you put any defined numbers in front of any variables. So we have 2xy times dy dx. And so what did we do? We subtracted 1 times y squared. Don't need the 1, so negative y squared. And we subtracted 2xy. So at this point, everything with dy dx is on one side, and everything without is on the other side. So what do? We factor out dy dx, because that's what these terms have in common, and we're only going to factor dy dx. Yes, they both have an x in common, but we want dy dx by itself. We don't want it with any other term. So when we factor out dy dx, we have x squared plus 2xy, and that equals negative y squared minus 2xy. So now what we're going to do is we're going to divide this whole quantity over to the other side. So that leaves dy dx by itself on the left, and on the right we have negative y squared minus 2xy all over x squared plus 2xy. And there is our derivative. So the big idea with this one is that when you have multiple instances of dy dx, you want to leave them on one side, and any term that doesn't have a dy dx, move it over to the other side. That's our first step in solving algebraically for dy dx, because every step after this is just algebra. The calculus part is right here in finding the derivative of these three. So let's look at the next one. Almost the same expression on both sides, but not. Here we have x plus y, and that quantity is squared. That right there is chain rule, because we have an expression inside of another one. So the outside function is that we're squaring it. The inside function is x plus y. So when we take the derivative of the outside, it's going to be 2, and we're going to leave the inside alone, plus times x plus y. But then we multiply by the derivative of the inside. So derivative of x is 1, and the derivative of y is dy dx. Over here, x squared becomes 2x. The derivative of y squared becomes 2y times dy dx. Now here we've got a dy dx on the left and a dy dx on the right. And what we're going to have to do is we're going to have to manipulate this equation so that both terms that involve dy dx end up on the same side. So we're going to have to expand this expression. So 2 times x times 1 is 2. 2 times x times dy dx. So that's 2x dy dx. 2 times y times 1 is 2y, and 2 times y times dy dx. So actually, we have two terms just on the left that have dy dx in them. So what do? Well, everything has to move from one side to the other side so that what we have is that all the dy dx's end up on one side. Since we have two terms with dy dx on the left, we'll do that. We'll subtract 2y dy dx. But notice, there's two of them, one on each side. So if I subtract 2y dy dx, what ends up happening is it cancels out this term right here. So that actually cleans this up a little bit, because now we're left with 2 plus 2x dy dx plus 2y equals 2x. So now we're just down to one term that has dy dx. Okay, we can handle this. So everything that does not have a dy dx, that's going over to the right side. So that's 2y and 2. Those are getting subtracted over. So 2x dy dx is going to equal 2x, which was there originally, and then we subtract the 2y and subtract the 2. And then finally, we have to divide everything by 2x. So dy dx equals 2x minus 2y minus 2 all over 2x. Now every term here has a 2 in common, so we can cancel that 2. So x minus y minus 2 all over x, and that's a 2, not a z. So here, when you have dy dx's on both sides, you got to get them on the same side once you take the derivative. Now it was coincidence for us that the dy dx's canceled out. That won't always happen. So let's look at number 7. Now here, we've got sign involved, but this is still chain rule. And so with chain rule, we have the outside function, which is sine, and then the inside function, which is x plus y. So with chain rule, the idea is that we have the outside function, we take that derivative. So the derivative of sine is cosine of x plus y times, and here we have the derivative of x is 1, and the derivative of y is dy dx. And the derivative of x is just 1. Now here we only have this one term. Now a lot of people get a mistaken idea that, like number 6, we can expand this, but we can't, because x plus y is part of cosine. It's not like a polynomial where we can multiply x plus y times 1 plus dy dx. So what that means is this is one expression right here, and so this doesn't have a dy dx in there, so this has to go over. We have to divide this quantity. So we have 1 plus dy dx, and that equals 1 over cosine of x plus y. Now for simplicity, we can rewrite that, because 1 over cosine is the same as secant of x plus y. And then we subtract 1. So dy dx equals secant of x plus y minus 1. And that is our derivative. Some people would prefer you leave it in this form. If we did that, then that would still be 1 over cosine of x plus y. And then this would be 1 over cosine of x plus y minus 1. And what other people, and if people wanted to leave it in this form, this would be a review of the fact that when you have fractions, you have to subtract them with a common denominator. So this would be 1 over cosine of x plus y minus cosine x plus y over cosine of x plus y. And so if you left it in cosine form, it would be 1 minus cosine of x plus y all over cosine of x plus y. Now this should be equivalent to this, so depending on how your teacher wants you to answer it, it's up to you which one you use. But here I'm showing you both. So now for this last one, what we've got is, we've got a little product rule again, because here we have x squared and multiplying by x squared plus y squared. Now I think for this one what we'll do is we will multiply the x squared in. So this will become x to the 4th plus x squared y squared equals y squared. And what I'm going to do is I see a y squared over here and a y squared over here. So there's going to be a dy dx that comes out of this when we take the derivative, and there's going to be a dy dx over here. Now it doesn't really matter whether you subtract before you take the derivative or after, but here I'm going to subtract before because I know what's going to happen. I know there's going to be a dy dx show up, so I'm just going to avoid having to subtract later. So I'm going to subtract x squared y squared. So now I can take the derivative. So the derivative on the left, derivative of x to the 4th is 4x cubed. The derivative of y squared is 2y dy dx. Now here we have product rule again. Now remember that we're subtracting this, and a lot of people make the mistake of only subtracting the first part of product rule. So that's why I'm putting a bracket here, to remind myself that it's not just the first part, but it's also the second part that needs to be subtracted. So product rule says we take the derivative of the first factor, which is 2x, and we leave the second factor alone. Then we leave the first factor alone, and then we take the derivative of the second. So now I knew that there would be two dy dx's. Why? Because we had a y here and a y here. That's why we subtracted. So at least they're on the same side. All right, so 4x cubed equals 2y dy dx, and now I will distribute that negative in. So minus 2x y squared minus 2x squared y dy dx. And so we have a dy dx here and a dy dx here, but this doesn't have a dy dx, so this has to move over. So we have 4x cubed plus 2x y squared equals 2y dy dx minus 2x squared y dy dx. Now that we have the two terms with dy dx, we can factor out a dy dx. And we're left with the quantity 2y minus 2x squared y. And on the left, we're still left with 4x cubed plus 2x y squared. So to get dy dx by itself, we will divide this quantity. So 4x cubed plus 2x y squared all over 2y minus 2x squared y equals dy dx. If you like this video, please give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for everyone for watching, and remember, the only way to understand something is to do it.